In section 1.3b, you did some simplifying with square roots, and I just kind of want to go over a couple of things we went over. To simplify, the number underneath here, which is the radicand, needs to be as small as possible, so you have to break it up into perfect squares and then take the square roots. Another thing is you can have no fractions underneath the square root sign, and you cannot have a square root in the denominator. It's okay to have one in the numerator, but not the denominator. So that's what we're going to go over today, and that's called rationalizing the denominator. And also, you always want to make sure anytime you're dealing with a fraction that it is reduced. So let's talk about rationalizing the denominator first, and then we'll come back and talk about combining like terms. In order to rationalize the denominator, if I multiply a square root by itself, the square root sign goes away. So here we have 3 times the square root of 5 over 2. Now, if I do this, I'm just going to do this up here. What is the square root of 2 times the square root of 2? Well, we learned yesterday that we can multiply if two numbers are under, each one is under a square root sign, we can multiply them together, so that would be the square root of 4, or it would equal 2. So anytime you multiply identical square roots together, the square root sign goes away. So that's going to be very helpful when we want to get the square root out of the denominator. So let's just look at this right here. I have a square root in the denominator, so what I'm going to do is multiply the denominator by the square root of 2. And that is just going to give me 2. Now the problem is if I do that, let's go back up here and think about what we do with fractions. If I have 1/2, and I multiply that just in the denominator by, let's say, 3, that's going to give me 1/6. Okay, I've completely changed the value of that fraction. Here it's 1/2, here it's 1/6. But if I do this, 1/2, and I multiply it by 3 over 3, that's going to give me 3 over 6, which is just another form of 1/2. It's not reduced. So this is just the same as multiplying by 1. So anytime you have the same numerator as the denominator, you're multiplying by 1. So that's why in this particular problem, we want to get rid of the square root of 2, so we're multiplying the numerator and the denominator by the square root of 2. Not changing the value, just rewriting it. So both of these are under the square root sign, so we're going to say, we'll put the 3 out from here, that's where this 3 comes, and then we multiply 5 times 2, leave it underneath the square root sign. But in the denominator, the square root of 2 times the square root of 2 just changes to the number 2. Now, whatever's underneath the square root sign, we can multiply together, so it's 3 square root of 10 over 2. This can only be broken up into 2 times 5, so that's as small as possible. So that takes care of number 1. We don't have any fractions under their square root sign. We don't have any square roots in the denominator, because we just rationalized it, and this cannot be reduced. So let's try a couple of those problems here. 4 over the square root of 5. This is our problem. We can't have a square root. You have to be careful where your square roots are. In one place, it cannot be as in the denominator. So we need to multiply. We need to get rid of the square root of 5, which means I'm going to multiply it by itself. And when I do that, it has to be in the numerator and denominator, because then that just means I'm multiplying by 1. So not changing the value any. So not under a square root, under a square root. Think of these as a radical sign. Numbers that are radicals do not mix with numbers that don't have radicals. So when we multiply those together, we can just say 4 square roots of 5, and that's it. Now the square root of 5 times the square root of 5, identical square roots multiplied together, get rid of the square root sign. So this is going to be 5. Now another way you can think about that is you could say the square root of 5 times 5 is the square root of 25, and that just is 5. So let's see if we have everything taken care of. The number under here is as small as possible. I don't have any fractions under the square root, and I don't have a square root in the denominator. So that final answer is just going to be 4 square roots of 5 over 5. All right, next one. We have a square root in the denominator again. So we need to rationalize the denominator. So that means I multiply the denominator by itself, and I have to multiply the numerator by itself. So think of this kind of, with equations, whatever you do to one side, you have to do to the other side. Think of that as a fraction. Whatever I do to the numerator, I have to do to the denominator. Otherwise, I'm changing the value of it. So I'm going to multiply straight across. So this is just going to be 1 square root of 6. And then the square root of 6 times the square root of 6 is the square root of 36, which just is 6. Now, some people may think that you are able to reduce this because they're both 6, but the problem is this is underneath a square root sign, this one is not. Those are two different types of numbers, so we can't reduce them. And we really don't have to write that 1 out there, so we're just going to write this as the square root of 6 over 6. Now, this next one's going to take a little bit more work because we're going to have to do some simplifying after we rationalize. We have a square root in the denominator, so we don't want that, which means I have to multiply it by itself, so numerator and denominator by the square root of 8. Okay, now, the two numbers that are underneath the square root get multiplied together. The number that's not underneath the square root stays out in front. So this would be 3 square roots of 16. And the square root of 8 times the square root of 8 is just 8. Okay, now, when we're finished, we always have to check. Now, this is not the same as small as possible. We can take the square root of that, so that would be 3. Square root of 16 is 4, so it comes out as 4 over 8. So that's going to give me 12 over 8. And here I can reduce. So 12, I can divide both of those by 4. So if I divide by 4, I'm going to get 3 over 2. I'm just going to put a box around these. Okay, so that's how we rationalize the denominator. The second thing that you're going to do today is add and subtract like radical terms. So they have to be like. And the way that we say that they're like is we check under here. If this number and this number are the same, we can add them together. Well, they don't look like they're the same. So what we need to do from yesterday, we need to make sure we simplify each one. So 3 times the square root of 2 can't be simplified. Then we have the square root of 8. Well, that's going to break into 4 times 2. That gives me 8, and the reason why I chose 4 is because 4 is a perfect square. So when we break that up, we have square root of 4 times the square root of 2. That changes to 2. So this can be rewritten like this. Now when we check, just going to get a highlighter here. This is the same as this. So when we add, think of it as being 3x plus 2x. These are the same. So we just add the numbers in front. Now, I really don't like how they do this here, but I guess you can see it. I won't cross it off. What they're doing is they're taking the coefficients, adding them together, and then writing the square root of 2. So here, we would just add 3 plus 2, and we leave that the same. Just like when we add 3x plus 2x, we say that it's 5x. We don't say it's 5x squared or anything else. So this stays the same. And we just count 3 and 2 to get 5. All right, let's try a few examples. The first one says add or subtract. I'm checking to make sure that these are called the radicands because they're underneath the radical sign. These are both the same, so all I need to do is subtract these two numbers. So 12 minus 4 is 8, and then I just write square root of 7. Now, these numbers don't look like they're the same, but 75, if I go down my list of perfect squares that I gave you the other day, I have 25 times 3 is 75. And so now I can do square root of 25, square root of 3, minus square root of 9, square root of 3. Okay, so that just turns into 5 square roots of 3 minus 3 square roots of 3. And as you can see, now we have the same radicand. So 5 minus 3 is going to give you 2 square roots of 3. And then you're finished. And I'm going to just put a box around that one as well. Okay, another one that doesn't appear at first when we look at it, that we can combine like terms, but this 45 we can break up into the square root of 9. What's that here? Again, going down my list of perfect squares, I don't want to use anything that's not a perfect square. Well, at least I should say one of them has to be a perfect square. Square root of 9, square root of 5. Okay, so that can change to 3. So now I have 6 square root of 5 plus 3 square roots of 5. I check underneath here. My 5s are the same. So now all I do is add the numbers in front. So that's going to be 9 square roots of 5. And then you're finished. So just a reminder, we need to make sure when we simplify that this number underneath the radical is or square root sign is as small as possible. We don't have any fractions under the square root, and we dealt with some of those yesterday. We can't have a square root in the denominator. That's when we rationalize the denominator, and we always have to make sure that we reduce our fraction.